one of these ways that we think the brain gathers information and shapes knowledge and creates concepts for different things is called conceptual space. Conceptual space is a geometric structure that represents a number of quality dimensions. I'm going to explain this, which denotes basic features by which concepts and objects can be compared, such as weight, color, taste, temperature. Even these days, the most advanced AI platforms are still working on the basis of conceptual spaces. It's a very basic but very important and popular idea of how should we create concept or create understanding in a machine. So let's start with a very simple exercise, an example that I have prepared for you. I have these headphones, but what I like about, there's a million things that I hate about them, but there's one thing that I like about them, and that is this profiling. So these headphones understand where I am. How does a device creates, shapes an understanding or creates a concept of places? That's basic question that we want to answer here. So first thing that my mobile is gonna do, or my headphone is gonna do, is to see what sort of sensor it has. How can it observe the world around it, right? The same way as we do. We use our eyes to understand the real world. We use our the hands to touch the real world. We use our tongue to taste the real world. So you need a sensor, right, to shape, to observe data, to observe information, and then interpret it as what is actually happening. So these things have a microphone on them. All they can do at the beginning is just to shape one axis, right, called noise level, and that's all they can do, right? They can't understand anything else because they don't have the basic tools to understand that. Now, I'm going to take these into different places. So first thing, I'm going to be in the living room, right? And my mobile would say, oh, the living room, it's a little bit noisy. Let's say this graph is like this axis is 0 to 100. The living room is somewhere in the middle. It's about here in 40, right? So this is going to be a living room. You know what you said about understanding something? I feel like the living room is around here, as based on what I can observe from the world around me. I might take my headphones to the street, and using the same sensors, it might say, oh, it's really noisy here. So this thing, the concept of a street must be around this area, right? And then it might say, oh, by the way, if you take me to like bedroom, the bedroom is about here. So based on what I can observe from the world around me using this single microphone that is on that is accessible to me, I'm shaping I'm observing different things, right? Different objects or different ideas around the place. Then I might say, okay, you observe these things, right? Let's look at something new. I take these to my office, for example. And now my poor headphone hasn't experienced the office before. So it might look at its sensor and say, you know what, this thing, this new place that you took me to, this new place is like if living room was 40, this thing is about 35. The noise level in it is about 35. So I'm gonna think the office is about the same look and feel as a living room, right? So it creates that idea of this is a living room, very close to that. So it starts understanding new things that it is sensing based on the things that it has in its memory, right? The thing that it already knows. The beauty of it is that after a while, you start observing more and more of these things within the same space, right? You might say, okay, the street, for example, I have been into a few streets in my life, and these streets are like mostly in this range, for example, right? And the living rooms are within this range, and maybe the bedrooms are like around here. Now, let's say I add a new dimension to the sensing of my headphone. My new headphone has a sensor for the GPS or location sensor as well. Suddenly, this single dimension becomes a two-dimensional. Did I do it right? Of course not. This dimension becomes a two-dimensional graph, right? Now I have this thing called, instead of just being the noise level, it is also the reception. When we talk about reception, it is a new dimension in my understanding of the world around me, or my headphones understanding of the world around it, right? So suddenly this idea of bedrooms being cramped into the corner of one-dimensional axis start to spread in the height as well. Why? Because the bedroom here with the bedroom in other places might have different receptions, even though they probably are the same sort of bad reception, but there is some similarity in this axis as well. So these ideas start to spread out. But the nice thing about it is that concepts that are similar probably stay within the same range in terms of reception. So the streets might have a really good reception. So they are probably very noisy and very good reception, right? But suddenly your living room and your office become separated. So your offices might have really good reception, right? But your living room might have the reception just enough similar to your bedrooms, for example. So suddenly we have a map of different observations, right? Now in this map, my headphones would be able to differentiate between the office spaces and the living room spaces. So if I throw a new observation at them, or I take them to a new place and say, oh, what do you think this is? If the new idea is around here in terms of the noise level and the reception, it is probably going to look at it and say, oh, this is very close to what I understand as being office, right? So I'm going to say, this new place that you have taken me is an office. And in their own sort of way, they would say, okay, so my owner is walking to an office, right? So I need to adjust the sound level based on my understanding of the place, right? So this new idea, so you see, the more observations the being has, right, in their own mind, they start to create these cloud things of shapes of the regions, right? The areas within the space, that multi-dimensional space, of that thing. Like the street would be around this region, the living room would be around this region, right? Some of them might be very precise because every observation is about the same. Some of them might be more broader concepts, right? So you, as somebody who is observing the world around you, you start to shape these regions of things. And whenever I threw a new observation at you, or you come across a new observation, what you do is basically you say, okay, you gave me this, I'm gonna evaluate the distance, right? I'm gonna see what is the closest concept I have in my mind, the closest to this concept. Is this the closest concept, or is this the closest concept? I really miss whiteboards. Or is this the closest concept, right? And then I can decide that, okay, I haven't seen this place before, but based on what I know, what the knowledge I have, this seems to be another living space, right? This is a living room place. Or it might be totally new and I can't really relate this concept to anything else in my sort of little space, right? So these cloudy things, we call them concepts, and they are shaped based on how many observations you have and how close those batches of observation are, right? They are a little bit, each observation is a little bit different. Each cup has a little bit of a different shape, a little bit of different handle, different weight, different sort of capacity. Based on how many dimensions you have in your space, you can map this concept of cup in different dimensions. But end of the day, you have this cloud of all the cups sitting in a corner in the space, right? In the conceptual space, with like a cloud of points, and we call them collectively, we call them the concept of a cup, or the concept of a street, or the concept of a mobile. So every object, every concept that you shape in your mind, it's actually that cloud of observations that you have. Now, two things out of this exercise, right? First of all, these concepts are shaped as basically clouds of observations that you have, and you can differentiate between them. The conceptual space, which is this multi-dimensional coordination system that we create, can have more than 3 dimensions. So this device might have another axis, which could be, let's call it, I don't know, it could see the light as well, like the brightness of the space as well. So there will be a third axis for the brightness. It could have another space, which is a sensor that now I can show more than 3 dimensions in a 2D sheet, but it can have another dimension for how many people are talking. It could recognize different people. So that is how the idea of concepts shape, and a conceptual space becomes the knowledge that we have based on our ways of understanding the world around us. Now, humans are very good at this. That's why we are the best at creating concepts, but everything that we talk about, down to a single word or an idea, everything is basically a concept in a multi-dimensional space, right? That's how we explain it. The beautiful thing about the conceptual spaces is this really nice piece, which is they're geometric. They are geometric. What does it mean to be geometric, right? Let's say, let me delete these. Let's say this concept is like the concept of an office is like 30 in noise level and 70 in reception. So suddenly it becomes a matrix, right? This is a matrix called, which is a 2-dimensional matrix, X and Y. The X is, the X is 30, which is the noise level. The reception quality is 70, right? That's the matrix. The street is like probably 80, right? The bedroom is 10 in noise and maybe 20 or 30 in. So you see, I'm writing matrices for each concept, right? Or each observation. And then when you give me this new concept, a way of evaluating this concept or this observation, this new entity that you have exposed me to, is to write the matrix for this, right? So I can write and say, this is about like 70 in noise and about 10 in reception, right? Now, the act of sort of evaluating the distance between this new observation to any other concept that I might have could be the mathematical transition between their matrices. right? It's geometrical. That's the beauty of it. That's why even today, when like with the most advanced AI sort of platforms, I don't know, TensorFlow. What is TensorFlow, right? Tensor means a matrix, and flow is the transition between matrices, right? So when we talk about Google's TensorFlow as being the most advanced AI platform, we are talking about a framework that allows you or the machine to generate these geometrical structures of concepts in a conceptual space with multi dimensions, and create for each concept, create those tensors or those matrices. And then for understanding new concepts or making new decisions or understanding new situations, to create flows between these matrices in a very mathematical way, right? That's the beauty of it. That's when the idea of conceptual spaces shows its strengths, right? So that's the definition of conceptual spaces.